Hello, this is the third of 3 videos demonstrating the functions of this power shield, right? So this is a shield that will fit on an Arduino, and it's meant to be part of a larger project, whatever project you have. But this shield allows other functions for powering the Arduino with a bit of programming. In this video, I'm going to show using this 555 timer as an external Watchdog timer. Now the Arduino, the chip on the Arduino, the Atmega328, it does have a Watchdog timer, but if by chance you set up a project and you let it keep running and you leave for a long period of time, there is a possibility that this chip could freeze and stop functioning even though the power is still connected. Okay, and possibly even that Watchdog timer could be affected by that. So this shield uses a 555 timer as sort of an external Watchdog timer to this, and it works by using one of the digital pins to ping this every so often, and as long as it keeps pinging it in a regular interval, then power will still keep going through these MOSFETs. Okay, and if by chance the Arduino freezes up, then that pinging would stop, and so then this 555 timer would actually power down these two MOSFETs periodically, or temporarily, that's what I meant to say. And then it would start up again, and the Arduino would start from the beginning, kind of like a reset, and then allow the function to keep going. Okay, so if it was doing something at that time, it's kind of stopped doing that, but at least now it's starting from the beginning and the function can continue and it can keep operating. Okay. So to do that, I need to make some connections. So again, here, this diagram is the diagram of the connections on here. And if I'm going to use this 555 timer, then I can't use this push button. But here I'm going to connect to the battery. So the screw terminals through the battery there. I got to connect my ATtiny to the battery. So there's a couple connections for that. So here, this is what controls, what powers these two chips. I'm not using an ATtiny 85, I'm just using the 555 timer, but I do want to connect this to the battery. So I need to connect that here to the left. So here it is here, the center pin to the left pin, right pin on the right side. Okay, these two. And then there's J10 here, which is right next to the 555 timer right there. So I need to connect that. So now the 555 timer will be connected to the battery. This group of pins here determines what keeps this going. And so now I want it connected to the 555 timer. So I need to connect the center pin, which connects here, to the bottom pin, which connects to the output of the timer. So I use this jumper here and connect the center to the bottom. Okay. Now there is some circuitry here. And by the way, I will explain this in another video on a breadboard. So it's maybe a little more clear than all of these connections. But I need to connect this here. So I have some options to connect this, either ATtiny 85 if I want it, or one of the Arduino digital pins. So let's connect the Arduino. So that's this set of 3 yellow pins here. And then I have decided to connect that to digital pin 5. Okay, so there's 3 rows of 3 here, so it's the middle one. And I'm going to connect to this yellow. So center to the one on the right. Okay, this pin is still connected. I'm going to connect to the V-in pin, so that's still here. Last, I need to connect my battery, but let's go to the computer. Okay, so here we are at the computer. Now, if you want a copy of this program, you can go to the Instructables associated with this video. But this is the program that's already installed on the Arduino. Okay, so the first variable that's declared is what pin I'm going to use to pulse the Arduino. So I'm going to use pin 5. Okay, here these two variables are for measuring how often I pulse the Arduino. Okay, pulse the Watchdog timer, sorry. So I need a variable to see when I last pulsed it. So I'm going to start that at 0. And then this variable here is how often I pulse it. So here's 10,000 milliseconds. So basically every 10 seconds. So the way the Watchdog timer is set up with its resistors and capacitors, it will time out every 12 seconds. So by setting this for 10 seconds, it gives me about 2 seconds leeway in case the Arduino's busy doing something. But if it doesn't pulse within the 10 seconds, then the Watchdog timer will turn off, which will turn off power to the Arduino. And then the Watchdog timer will turn on again, which will power up the board again, and it'll start from the beginning of its program, the beginning of this program. Okay, but it's a way of resetting it in case it got stuck. I have a dummy function on here again, so I'm gonna again flash that LED on pin 13 twice, okay, double flash, just to show in this video, okay? In my actual project, I wouldn't have this, but this is just to show you that the Arduino is doing something. Here is my pulse WDT, pulse Watchdog timer. So this is the function where I actually pulse the Watchdog timer to keep power going. So I just pulse the pin high, cause a short delay. I haven't actually determined how short that delay can be, but anyways, right now it's 5 milliseconds. And then I turn that pin off and I update my last pulse variable. So I know when to pulse again. Okay, here down in the setup, again, so here I declare my pulse pin as an output, and here's where I first call that pulse Watchdog timer function. Okay. Again, I'm going to use my dummy function, so I wouldn't normally have this, but just for this video, I'm going to declare that pin as an output, and then I call this do something function, which is right here, which again, I'm just going to double flash that LED, okay, just to show you that something is happening. Now down in the loop, I'm going to check millis. So millis just tells me how many milliseconds since the Arduino was last reset. So it just counts up from the beginning. And if it's greater, or sorry, compares it to this last pulse. And if that's greater than my next pulse interval, which again is 10 seconds or 10,000 milliseconds, then it's going to call this pulse Watchdog timer because it's time to pulse my 555 timer. Okay, if it misses this for some reason, then the Arduino would reset. Okay, otherwise it'll do this, do something which double flashes that LED and then causes a small delay. Okay, and that's it. So you'll notice there isn't any push button programming in here because I'm not using the push button in this one. You sort of can't because the 555 timer needs constant power, so it knows that if it does turn on, it's able to, you know, sort of turn back. So if it does turn off, it can turn back on. This only takes 3% of the memory, 0% of the dynamic memory. Okay, so lots of space for whatever bigger project you actually have. So let's go to the Arduino. So here we are. I have the battery terminal on, and like I said, my do something function is going to be flashing this LED. So let's connect the ground rail to ground, and we connect the anode to my pin 13. Okay, and that's connected to this 220 ohm resistor, which is connected to the ground rail. Okay, so now as soon as I plug in the battery, it should actually start the Arduino going. Okay, so there's my do something function. It's just flashing. So one thing you can't see is actually this pulsing that's going on here. So why don't I actually add my red LED back here. Okay, so I'm working backwards. So it's a very, like I said, it's only 5 milliseconds, so it's a very quick pulse, but you should be able to see it. And it's only every 10 seconds. Right there. So that quick pulse went through the circuitry, pulsed to this 555 timer, and kept the power going. Okay. So for example, if I disconnect this jumper here, now even though the Arduino flashes that pin, and you'll see it there, it didn't flash this because it's not connected. So it's going to power off and then power back on again and start going. But again, it's not connected, so it's gonna time out. Okay, and so that's how the Watchdog timer works, is it powers itself off, powers back up, and it will keep going. Okay, I reconnected it here, so this shouldn't stop, and then this you should see that quick flash right there. Okay, so that's what the external Watchdog timer does. And so again, the idea is if I had a larger project, I could put that in here, connect it to, power, walk away, and I shouldn't have to worry about if the Arduino ever froze or something went wrong, that it would stop functioning, right? And, if I leave it for days and it could be sort of malfunctioning for days, at least this would prevent that from happening. Okay, it would be off for just a couple seconds and it would come right back on again. Okay, so that's the function of my external Watchdog timer.